3 stages using charcoal pots. In the charcoal pot, at the bottom, carbon combines with excess oxygen. At the bottom, carbon combines with excess oxygen to give you carbon 4 oxide. That reaction is taking place at the bottom. At the middle of charcoal fire, carbon combines with carbon dioxide. Carbon combine at the middle. Carbon combined with carbon dioxide. Carbon dioxide is also known as carbon 4 oxide. So when carbon combined with carbon dioxide, it gives you carbon 2 oxide, which is also known as carbon monoxide. And this is the reaction. So this one is taking place at the middle of charcoal fire. Then at the top of charcoal fire, you have carbon monoxide combining with oxygen. At the top of charcoal fire, you have your carbon monoxide combining with oxygen. Carbon monoxide, that's carbon 2 oxide combining with oxygen. So here, this one will give you carbon 4 oxide. So in this reaction, carbon 4 oxide is formed at the bottom and at the top, while carbon monoxide is formed at the middle of the charcoal fire. Coal. Coal was formed from the vegetation of the Carboniferous era, which was protected from complete decay by overlying water-washed earth deposits. The different types of coal that we have are peat, lignite, bituminous coal, and anthracite. These are the examples of coal that we have, types of coal that we have. Industrial distillation of coal. This is a very important process because so many important components are being generated during the industrial distillation of coal. What is industrial distillation of coal? It is the process by which coal is subjected to a very high temperature in the absence of air to drive away all the volatile constituents. When they say volatile, that means they easily evaporate. An example of a volatile substance is your methylated spirit. The products obtained from this process are coke. One of the products obtained, you have coke, you have your coal tar, you have your coal gas, and you have your ammonical liquor. These are the 4 processes, or these are the 4 products that are obtained during industrial distillation of coal. Coke. Coke is used in the extraction of metals. How is it used in the extraction of metals? When copper oxide combines with coke, coke is carbon. You have copper 2 plus CO2. This coke has removed oxygen from copper 2 oxide. So it ensures a separation of this metal. So that is one of the essence of coke. The second one is ammonical liquor. Ammonical liquor is used to manufacture fertilizers. They use it to manufacture fertilizers. Coal tar. Coal tar is used in road surfacing. They used to surface the road. Coal tar. And coal gas is used in synthetic gases. Is used in synthetic gases. What are synthetic gases? Synthetic gases are also known as water gas, and that is the combination of carbon 2 oxide and hydrogen. So this is what is referred to as synthetic gases. Gasification of coke. The coke that I refer to here is carbon, not Coca-Cola. The gasification of coke produces producer gas and water gas. The two components being produced in the gasification of coke, the first one is producer gas and the second one is water gas. What is a producer gas? It is a mixture of 1/3 of carbon 2 oxide and 2/3 of nitrogen by volume. So producer gas is equal to 1/3 of carbon 2 oxide and 2/3 of nitrogen. So this is known as producer gas. How is it obtained? How is producer gas obtained? It is obtained by heating coke in a furnace in limited air. It is used as a fuel in furnaces and manufacture of ammonia. So in the producer gas, you have 4 nitrogen combining with oxygen, combining with 2 coke. Here you have 4 nitrogen gas plus 2 CO. This is what is referred to as producer gas. This is what is referred to as producer gas. Water gas. Water gas is the second component in the gasification of coal. How is it produced? It is produced by passing steam through hot coke at 1000 degrees Celsius. When you pass coke into steam at the temperature of 1000 degrees centigrade, what you have is carbon 2 oxide plus hydrogen gas, and this is what is known as water gas. You can now see the difference between producer gas and water gas. It is used as a fuel and as a source of hydrogen and other organic compounds. Oxides of carbon. The first oxide of carbon is carbon 2 oxide. Carbon 2 oxide is commonly prepared by dehydrating ethane dioic acid with concentrated tetrasulfate 6 acid. Ethane dioic acid. This is the formula: COOH. Bond COOH. When you react this with concentrated tetrasulfate 6 acid, which act as dehydrating agent, what it does to the system is to remove water. It will remove water. So maybe H from here, H from here, and OH from here. So automatically you will have CO2 plus CO. So this concentrated H2SO4 act as dehydrating agent. So to give you carbon 2 oxide as a product. So this is one way of preparing carbon 2 oxide. Carbon 4 oxide is a constituent of air consisting of 0.03% of air by volume. It is always present in rainwater and does not support combustion. It does not support combustion. And it can also be prepared by dehydrating ethane dioic acid with concentrated H2SO4. Such process requires to produce carbon 2 oxide can also be required to produce carbon 4 oxide. Carbonic acid. Carbonic acid is another important acid. Carbonic acid is produced when carbon 4 oxide combined with water. When carbon 4 oxide combined with water, then you have what is known as carbonic acid. This is what is called carbonic acid. Carbonic acid is triazocarbonate 4 acid. Another name for carbonic acid is triazocarbonate 4 acid. The triazocarbonate 4 salts are salts derived from triazocarbonate 4 acid, which is the carbonic acid. Examples of such salts are potassium, magnesium, and ammonium carbonates, hydrocarbons. What are hydrocarbons? Hydrocarbons are organic compounds containing carbon and hydrogen only. You must always incorporate only into it, because the two constituent elements that you have in hydrocarbon is carbon and hydrogen. The major classes of hydrocarbons are aliphatic and aromatic hydrocarbons. What are aliphatic hydrocarbons? They are straight-chained hydrocarbons, and the typical examples are alkanes. What about aromatic hydrocarbons? Aromatic hydrocarbons are the family of benzene. Examples are benzene itself, you have your phenol, you have your xylene. Benzene, you have your, this is benzene, this is phenol, OH is attached, phenol. So these are examples of aromatic hydrocarbons. The importance of hydrocarbons in chemistry is broad, such as in fuels, agriculture, carbon dating. Carbon dating is used to detect the age of ancient tools. Tools of 1600 years ago can be determined by using carbon dating to determine the age. Crude oil. Crude oil was first discovered in Nigeria in 1956 at LIBERIA. Full stop. It forms the mainstay of Nigerian economy. When I say mainstay, that means the way of survival of Nigerian economy is based on crude oil. Questions that are attached to this topic. One of these is not a reaction of carbon. A, carbon reacts with oxygen to give carbon dioxide. B, carbon dioxide reacts with carbon to give carbon monoxide. C, carbon monoxide reacts with oxygen to give carbon dioxide. Based on this question number 1, the 3 reactions in charcoal fire, at the bottom you have the formation of carbon 4 oxide. At the middle you have the formation of carbon 2 oxide, and at the top you have the formation of carbon 4 oxide. So the only one that is odd here is option number D, which is carbon dioxide. Carbon dioxide reacts with carbon monoxide to give carbon monoxide. This is odd because it is impossible. So this one is not involved in the reactions in the charcoal fire. So the answer to question number 1 is option D, which is carbon dioxide reacts with carbon monoxide to give carbon monoxide. Question number 2. When graphite is subjected to a high temperature and pressure for several hours in the presence of nickel catalyst, the product form is A. soot, B. quartz, C. artificial diamond, D. graphite. Option D is wrong, because graphite being subjected to high temperature cannot give you graphite flakes. Quartz is also wrong. Artificial diamond is also wrong. And you know the properties of graphite is that when you subject it to a very high temperature, you have carbon, which is known as the charred carbon, which is known as soot. The charred carbon, which is known as soot. So automatically the answer to the question number 2 is option A, which is soot.